So we're going to talk about the double angle identities, and in this video first I'm going to prove the identities and then I'll go through different exercises that use the identities, so hopefully you have a pretty good sense of them. So we're going to start with the identity cosine of 2a. Okay, so just to prove how this identity works to you, so you can break this up into cosine of a plus a, and then we can use this identity here, which I've proven in another video, so cosine of a plus b. So I can basically just apply this idea to what I'm working on now. So there you go, I've applied that. And now you'll notice I've got cosine times itself and sine times itself. So that just simplifies to cosine squared a minus sine squared a. So this is one identity, but there are others. So let's keep going. So now what I want to do is, I just want to remind you, right, this is what we just proved. Okay, that's what we just proved. And so now I'm going to use the Pythagorean identities to help me play with this a little bit. So I'm going to use this Pythagorean identity here, and specifically I'm going to just rewrite this as cosine squared theta equals 1 minus sine squared. Oops, that should say theta, not a, my bad. Okay, so anyways, so now if I apply that to what I'm looking at here, so this cosine squared a minus sine squared a now becomes 1 minus sine squared a minus sine squared a. So if I go ahead and I just collect my terms, this leaves me with 1 minus 2 sine squared a, and this is another identity. So cosine of 2a also equals 1 minus sine squared a. And okay, one more time, now to do this again, I could also use this Pythagorean identity and I could go the other way. So I could say sine squared equals 1 minus cosine squared theta. So I could make that substitution, and so turning this sine squared a into 1 minus cosine squared a. And now what do I get? Well, if I collect my terms, now I get 2 cosine squared a minus 1. And so there is your final identity. So we can do a couple of things with cosine of 2a. All right, so now let's talk about sine of 2a. So I can do the same trick, right, where I can break this up, sine of a plus a. And then I can use my identities that I discussed in another video, sine of sum and sine of a difference. So I can use this one right here. So I'm just going to plug everything into this identity. So it's going to look like this. And okay, so these are really the same thing, right? Sine a, cosine a, sine a, that's the same thing. So this just becomes 2 sine a, cosine a, and so that's the next identity. So that is the identity. That's it, we're done. So that's kind of a simple one to prove. And then the last one I want to show you is tangent of 2a. So of course we know with tangent of 2a, so I could break this up just like I have with all the others, tangent of a plus a, and then I can just, boop, take my tangent of a plus b, so I can just apply this identity here. So if I go ahead and I do that, so you can see what happens when I plug in all those a's into the identity, and then I can really simplify all of this into 2 tangent a over 1 minus tangent squared a. And so this would be the identity. Okay, so I've gone through a bunch of identities kind of quickly here, so I just want to take a moment to show you the list of the identities that I've just proven to you. And so, if you need to write them down or something, you probably want to have them in front of you if you're watching this video, so make sure you write them down, pause the video if you need to. And so now I want to go through a bunch of different exercises of how to use these identities. So let's start with this first one. So given sine of theta equals 5/8 and cosine of theta is less than 0, find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta. Okay, so let's start with sine of 2 theta, which I know is 2 sine theta cosine theta, so using the identities that we just came up with, right? All right, so I know sine of theta, that's what's given, but I need to find cosine of theta. And so, I've talked about in a couple of videos now different ways that you can approach this. I could just use the Pythagorean identity to help me figure out what cosine of theta is. So for sine squared theta, I'll just plug in the given information. So I can plug that in, and then I can just do the work to solve for cosine of theta. Now, notice that when I solved for this, I have cosine of theta equals negative square root of 39 over 64. That comes from the given information. That was given to me in the problem. And then I could simplify this to the negative square root of 39 over 8, I guess, if I wanted to. So I'm just going to note that over here, and then I'm just going to plug these in. So sine theta is 5/8, cosine theta negative square root of 39 over 8, so I can just multiply that together, and I get sine of 2 theta is negative 5 times square root of 39 times all of that over 32. All right, so there's that. Now, let's move on to the next part of this problem. That was sine 2 theta, so now we've got cosine 2 theta. And you know cosine of 2 theta, so we've got 3 options here. So as I'm assessing my options, so here's the deal. You can use this one, or this one. Is there a best choice? I would say yes, there is a best choice in this case. I would use this particular identity because so if you think about it, we just calculated, sorry, I just had to think of what did we calculate. We calculated cosine of 2a, and we calculated some information off of that, but the nice thing about using this particular identity, this allows us to leverage all of the given information. So you want to do that because just in case you made a mistake in how you calculated cosine of a, if you flubbed that, at least this won't have that error kind of present. So this is the best choice to make. So hopefully that makes sense. Okay, so okay, let's see. Let's keep going with this. All right, so I'm going to use that identity. Sometimes there's the best choice, by the way, sometimes there isn't. So anyways, I chose that identity. And now I can just plug in that 5/8, right? And then it's just, you just finish the math and you're good to go. And next we have tangent of 2 theta, so now I can just use my double angle identity here. So, all right, so no problem. Well, okay, maybe some problems. So I do have to think of tangent of theta, which is sine of theta over cosine of theta. So now I do have to actually compute what this is, so I have to use some of the information that I've computed so far. So sine of theta is 5/8, cosine of theta, we calculated this a little bit earlier, right? So that was something that we found here. So all of this information, or all of this calculates to -5 over the square root of 39. Now, I should rationalize this, but I'm not going to rationalize it until later because I need to do some more calculations with this. So I'm just going to note this over here for now, and then I'll figure out what to do with it later. So, okay, so I'm going to plug in my tangent of theta as you see here. And so now I've just got to do the algebra to sort this out. So I'm left with this. And so, okay, I'm left with this calculation. So if I finish this calculation, so I can divide by 14 over 39, which is equivalent to multiplying by the reciprocal, right? And then I can do this whole calculation here. And this just gets a little computationally heavy or funky, I guess. So I go through and I multiply everything, and then I do want to rationalize, so I can go ahead and multiply the top and bottom by the square root of 39 like you see here. So then I'm left with this. So 39 actually goes into negative 195. So this whole thing will simplify to -5 times the square root of 39 over 7. So it was a little bit of work to figure that out. Okay, and so yeah, so that takes care of it now. We have found all 3 parts of this problem. Okay, now a slightly harder problem would be to find the values of the 6 trig functions given that cosine of 2 theta equals -11 over 13, and we're told that theta is between 180 degrees and 270 degrees, i.e. this means that theta is in the 3rd quadrant, right? So you do want to just kind of mentally keep that in mind. Okay, so all right, how do I want to think about this? Well, first of all, I think through my double angle identities, and we're talking about cosine here. So what I want to do is I don't want to have too many variables to solve for. I need to figure out what is the value of either sine of a or cosine of a. So this identity here has 2 different a's in it. I want to have just one a in my equation. So I can choose either one of these. It really doesn't matter. So I'm just going to choose the first one. So cosine of 2 theta is equivalent to 1 minus 2 sine squared theta. And so now I'm going to set that equal to -11 over 13. And this allows me then to go through and actually solve for sine of theta. So I can set this up, and I can go through and I can solve for sine squared theta. So you can see I'm kind of going through the motions here. I can divide both sides by 2, which when I divide by 2, that's equivalent to multiplying by 1/2, right? So what I get now is that sine squared theta is going to equal 12 over 13. And so then when I take the square root, this comes out to negative square root of 12 over 13. How do I know that it's negative? Well, again, this given piece of information here, right, that's quadrant 3. And if you think through, all students take calculus, so we're in the 3rd quadrant, so it's going to be negative. Whew. Okay, so now that we have this, because I have to find the 6 trig functions, I think the easiest thing to do in this case would be to have a sketch, because then if I have a sketch, I can kind of just read off the values. So, okay, so here I've got sine theta equals negative square root of 12 over 13. And like I said, we know that our theta falls into this third quadrant, so I can go ahead and draw a line here. And so here's going to be my theta. And so sine of theta, that's opposite over hypotenuse. So here's my opposite side, here's my hypotenuse side. And then you know how this works. So you can use the Pythagorean theorem to solve for the missing side. So I think personally you have enough information to finish this problem. Remember, we're trying to find all 6 trig functions. I would encourage you just to pause the video here and see if you can finish this and get the same answers I do. Okay, so the missing side is going to be -1. Remember, this side is negative because, again, we're in quadrant 3 here. And so now I can just go through and find my other trig values. So I've cut this down just to give myself a little bit of space over here. Okay, so starting with cosine of theta, so that's going to be, so the adjacent over the hypotenuse, so that's -1 over the square root of 13, and then I have to rationalize it as shown. And then I've got tangent of theta, so that's going to be now my opposite over my adjacent, so I get this, so this just becomes square root of 12. Cosecant of theta, so that's going to be taking the reciprocal of sine, so as you see here, and then I did rationalize this. And then secant of theta, which is going to equal negative square root of 13, and then cotangent of theta is going to be square root of 12 over 12, and then just as a reminder, make sure you rationalize this. I'm going to omit that for now because I'm running out of room, but you know, once you kind of get that sketch in, I think it's kind of clear, you know, what else you need to do. Okay, so other types of exercises. Of course, you could have to verify some trig identities. So I've got a couple of these here that I'm going to walk you through of how to leverage these identities. So I've got sine x plus cosine x squared equals sine 2x plus 1. So this is just screaming for us to like multiply this out, right? So if I multiply out this side here, I get sine squared x plus 2 sine x cosine x plus cosine squared x. And now, looking at that, I see the sine squared x and the cosine squared x, so that's a Pythagorean identity, so that actually equals 1. So now I'm left with 1 plus 2 sine x cosine x, and now, looking at this guy right here, I can now go to my double angle identities, and lo and behold, 2 sine a cosine a equals sine 2a, so I can apply this now to what I'm trying to verify. So this will turn into sine of 2x, and that was exactly what I was trying to verify, right? So I have done that. And then for the other identity I have here, so I've got cotangent x minus tangent x over cotangent x plus tangent x equals cosine of 2x. Okay, so we're going to start on this side again because it looks more complicated, and so I'm just going to go through and write this whole side in terms of sine of x over cosine of x. So I just blow everything out here, so cosine of x over sine of x minus sine of x over cosine of x, so on and so forth. So I write all this out. Okay, so this looks very complicated, so what I want to do is I want to clear the fractions. So what I would suggest here is, you know me, I always think that math is not a spectator sport, so you should pause and see if you can clear the fractions and finish this one. If you're struggling with verifying trig identities, then you've really got to get in the game to start understanding them. So I've given you a big hint. Give it a try. Hit play when you're ready. Okay, so if I'm going to clear the fractions, I'm going to multiply everything by sine x cosine x. So I multiply the top and bottom by this. Okay, so in doing that, let me just like blow out the work here. So I've given myself a little extra space right here. So here's a little extra space. So I'm going to go ahead and I'm going to distribute. So I want to just show you nice and clearly. Here's all of that work. There's me multiplying every single part in the parentheses by sine x cosine x. Don't be afraid to write out this level of detail if you find that you're making a lot of mistakes, because now you can go through, I can see the sines here will cancel out. Cosine cancels out, sines cancel out, cosines cancel out, so on and so forth. Okay, so what am I actually left with then? I'm left with cosine squared x minus sine squared x over cosine squared x plus sine squared x. And now I know that this part here, this equals 1. And then I know from my list of identities, right, this is where we started today, this is actually equal to cosine of 2x. And so I have that this ultimately equals cosine of 2x, which, just to take you back to the very beginning of the problem, that was what we were trying to verify. So we have verified, we're good to go. Okay, so cool. A couple more exercises I want to go through with you. So what about how to simplify using these identities? So what if I have something like sine squared 15 degrees minus cosine squared 15 degrees? Okay, well, now this actually is a little tricky because you'll notice that the identity, right, is cosine squared a minus sine squared a. It's not, it doesn't start with sine. So what I need to do to this is I need to manipulate this so that I can use my identity. That's what I want to do. So to do that, whenever that doesn't go in the order that you want it to go in, you can factor out a negative, and when you factor a negative out of the expression, you're allowed to flip the order of the expression as you see here. And okay, so now I can apply that identity that I wanted to apply here. So when I apply that, this becomes negative cosine of 2 times 15 degrees, which is just cosine of 30 degrees. And then I can just go to my handy dandy unit circle and I say, oh, 30 degrees, look at the x coordinate. So this equals negative square root of 3 over 2. Okay, up next. So very similar idea actually. So I've got sine squared 3 pi over 5 minus cosine squared 3 pi over 5. Okay, so I recommend that you pause video here. Just simplify this as much as you possibly can and then hit play. Okay, so once again, so we're still dealing with the same double angle identity. So we have this same order issue, right? I have sine coming first instead of cosine coming first. So it's the same trick that I just showed you. So I'm showing it to you twice. So, all right, I've flipped my order of everything. And now that I've flipped my order, I can apply my identity. So I can just take negative cosine of 2 times that 3 pi over 5. And so then this becomes negative 6 cosine pi over 5. I can't simplify this farther without a calculator. So, and I know how to plug something in with a calculator. So this is as far as I can simplify this. So we're going to call this good and simplified for now. Okay, and the last exercise that I have for you is, okay, so let's write cosine of 3x in terms of cosine x only. So I want to get rid of the 3, and I want some sort of function that's only in terms of cosine. Okay, so this is where you get a little bit clever with some of these things. So cosine of 3x, I could actually rewrite that as cosine of 2x plus x. And so this now is screaming for me to use my cosine of a sum, right? So I can use this identity here. Okay, cool. So I'm going to go ahead and apply that identity as you see here. And now, what do you notice? What else can I apply? Well, now I've got this cosine of 2x and this sine of 2x. And so now I have to use my double angle identities. And, you know, just totally randomly, what happens if I don't think too much about which cosine identity that I need? So what if I just take the first identity, and then of course I have no choice for sine of 2a. So I'm just going to plug in these two identities just so you can kind of see what happens. So my cosine of 2x now is cosine squared x minus sine squared x times cosine x, and then my sine 2x is now the 2 sine x cosine x sine x. Okay. All right, so now it's time to do some algebra, you know, distribute things, whatnot. So I distribute this cosine x to get cosine cubed x minus sine squared x cosine x. And then this term here becomes sine squared x cosine x. So, okay, now I have these like terms. So I can go a step farther so that this becomes cosine cubed x minus 3 sine squared x cosine x. Oof, okay, so now, am I done? No. What was I doing? Can somebody remind me? Right, cosine 3x in terms of cosine x. Right. Okay, the problem is that I have this sine squared x. So now I need to get rid of that. So where I have this sine squared x, now I'm going to replace it with 1 minus cosine squared x. So I just use that Pythagorean identity. I'm assuming that you know that identity pretty well by this point. So I've made this replacement, and now I have to distribute one more time. So I distribute again this cosine into here, and then after I distribute all of that, and I collect all my like terms, I end up with 4 cosine cubed x minus 3 cosine x. Whew. All right. Okay, and so that brings us to the end of this video. If you found it helpful, it's always appreciated when you guys leave me a like, comment, share, subscribe, all that good stuff. And otherwise, thanks for watching, guys. I'll catch you in another video.